Hello. In this video, we're going to learn to sketch the trig functions that we've been studying. In particular, I want to start with sine of theta. So what if we had the equation y equals sine of theta? Could we sketch this as a graph? Well, I think so. And what I'm going to do is start with a little table of values. So we have theta and we have y. So if theta is 0 degrees, sine of 0 is going to be 0. We know that from the unit circle. So we have our first point right here. The next unit circle value we know is 30. So at 30 degrees, sine of 30 is 1/2. Now, I'm not exactly sure where that'll be on this x-axis because we have a 45 there, but a little bit before the 45, probably right about there. Now for 45, sine of 45 is root 2 over 2, which as a decimal is approximately 0.7. So that's pretty good. We could kind of eyeball that one. So at 45, we'd have maybe about here, 0.7. Then the next one we know is sine of 60. So sine of 60 degrees is root 3 over 2. So that's going to be approximately 0.866. That's going to be somewhere around here-ish. And then at 90 degrees, we know sine of 90 is 1. So for the first chunk of this graph, I think we've got a good idea. It looks sort of like this. And I encourage you to pause the video and see what you come up with for the next chunk of values. If you want to do all the values on the unit circle, that's good. If you just want to grab these ones here that are highlighted along the x-axis, that's okay too. But pause the video and see what you come up with. All right, so assuming you gave this a try, sine of 135 is going to be, again, that root 2 over 2, which is going to be about 0.7 here. Sine of 180 is back to 0. Sine of 225 is going to be that negative root 2 over 2. So that's about down here. Sine of 270 is negative 1. And then here, and then back to here. And so if we connect these dots with a nice smooth graph, we should have something that looks like this. All right, so there we go. That's the graph of sine of theta. Let's go ahead and compare it with a nice sketch on Desmos, just to make sure that our graph is good. All right, so if we take a look at Desmos here, yeah, this looks exactly like what we have. The graph of sine x starts here at the origin. It goes up to a peak at 90, down through the x-axis, down to a minimum here, and then back again to the x-axis at 360. So this is the graph of sine x, and I definitely think it looks like a wave. Okay? You can imagine like a wave in the ocean, right? The water going up and down and up and down. That's what we have here for sine. It's a very cool graph. And what I really like about it is that we could actually get this graph without all of the points. Once we know the general shape, just like other graphs, as long as we find the key points, it'll really help us sketch it. So what I would encourage you to do is pause the video and think about the 5 key points you might use to sketch sine of theta. All right, so assuming you gave this a try, we're thinking about just 5 points. And if you picked all 5 points along right here, I mean, I guess there are 5 points there at 0, 30, 45, 60, 90. But those 5 points only really give us the start of the graph. I wouldn't pick those 5 points if I was forced to pick 5 points. I think I would pick the following. I'd pick the beginning, I'd pick the top, I'd pick the middle, I'd pick the bottom, and then back to the middle again. Those would be the points I would pick. Now this first point is at 0, 0. The next point is at 90 and 1. 180 and 0, 270 and -1, and 360 and 0. Those are like our 5 key points that define the graph, and using them, we can just sketch the graph right away. Let me show you. So we've got a blank XY axis, and we can simply go 1, 2, 3, 4, and 5. And then we make a nice, beautiful wave shape between them. This is up at 1. This is down at -1. This is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So by simply picking those 5 key points, we can get a rough shape of our graph right away. Now let's go ahead and do the same thing for cos. Let's get a sketch of the graph of cos theta. But again, just use 5 key points. So over here for your table, when you're picking your theta values, just pick 0, 90, 180, 270, and 360. And then find cos of each of those values. So pause the video and give it a try. All right, you should have the following. Cos of 0 is 1, cos of 90 is 0, 180 is -1, 0, and back to 1. So we're going to go up to 1, down to -1. I got 1, 2, 3, 4, okay, just like that. So we got 90, 180, 270, and 360. So up, middle, down, middle, up. Now the only problem with these points is sometimes students are tempted to do this and just kind of connect them with really sharp lines, or maybe kind of like this, like upside down triangle or something weird. And that's not the graph of cos, because cos is also going to be a wave. Just like sine, cosine looks like a wave. And so we need to kind of give it those wave characteristics, nice curvy lines as we connect them. If anything, I like to think about cos as like a valley. Okay, it looks like you know, a hill would look like this, right? This would be a hill. And cos looks like a valley. It looks like you've gone down a valley and then up the other side. Now, I just want to show you a nice Desmos animation here before we move on, because it's cool to see how these graphs relate to the initial unit circle, because that's, of course, where these are coming from, right? These are all coming from the unit circle. And so it's nice to actually see a little animation connecting the unit circle to these graphs. Okay, so here we have the unit circle. And what we're going to do is slowly trace around the unit circle. And as we get different y values, we're going to trace those on the graph. So we go up, then we go down, then we go negative values, and then we go back to the beginning. And we can see here that as we sort of trace around the unit circle, as we kind of unwind the unit circle, those values trace along our beautiful sine graph. And so I just think it looks really cool, this connection between the unit circle and between the sine graph. Of course, we could do the same thing for the cosine graph. But there's this nice connection, of course. The sine graph and the cosine graph, they're not really new topics. They're just extensions of the work we've been doing with the unit circle. Okay, so since we have a graph, we should probably start to do some transformations to it. What if we were to sketch the graph of y equals sine theta plus 2? In other words, the 3 here is going to be a vertical stretch by a factor of 3. Factor of 3. The 2 is going to be a vertical translation of 2 units up. In other words, any point we had before xy is going to become the same x, but the y is going to be 3 times the y and then add 2. So we have to take our y values and multiply them by 3 and add 2. The best way to do this is to start with our initial xy table, right? Because we have the base graph, and then we'll create the new graph. So this was 0 degrees, 90, 180, 270, and 360. And the y values for sine were 0, 1, 0, -1, and 0. Then when we make our new graph here, maybe I'll do this in green here. These are our new values. Well, the x's stay the same because there's no x transformations happening. But the y values get multiplied by 3 and add 2. So 0 times 3 is 0 plus 2 is 2. 1 times 3 is 3 plus 2 is 5. 0 is back to 2. Minus 1 times 3 is negative 3. Plus 2 is negative 1. And then back to 2. So along the x-axis, it's 90, 180, 270, and 360. And then along that y-axis, 1, 2, 3, 4, 5. Okay, so we've got 2, we've got 5, 2, negative 1, and 2. So again, we connect the dots with that nice, beautiful sine shape, and we have the graph of sine x, or 3, I should say. We have the graph of 3 sine theta plus 2. Now, I want to compare this to Desmos because while this graph is good, we're technically missing something. So if we look here, we have the points that we sort of expect. We have 0, 2, we have 90 and 5, we have 270 and minus 1. But this graph looks a little different from our graph, and in particular, it's because it just keeps going. If you notice here, the graph goes all the way to the right. It goes all the way to the left. In fact, if I zoomed out a little bit, we would see that this graph just keeps repeating forever in either direction. And that's because with the unit circle, you could keep going around and around. You don't just have to have one revolution. So the graph of sine of theta goes both directions. It has a domain of minus infinity to infinity. The domain here would be minus infinity to infinity. And so what that means is on our graph, well, first off, we should probably be adding arrows, because if we only have a little sketch like this, we know it continues in both directions, so we should definitely add some arrows. And I think it would be good practice to take the initial sketch we have and to add a couple more copies of the graph. When we have just one section of the graph, this is called a period. And that's the length of time before the graph repeats itself. So we have drawn, in some ways, the full graph of sine x, but we've only drawn one period of it. When you think about the graph here, we have one section right here, and then the graph has been like copy and pasted. So there's another copy over here, there's another copy over here, and so this is one period of the graph, and then we just copy and paste it all the way to the right and all the way to the left. So generally speaking, when we're drawing the graph, I'll only ask you to draw one period. But it's nice to extend that period one to the right and one to the left, so we can really see how that graph just keeps repeating and repeating and repeating. So let's jump back into our example. Let's try to extend it one period to the right. So that would mean we have to keep adding more points. This would be up by 90, so 450. Okay, let me do that in another color here. This would be 450, 540, 630, and 720. And then the y values would keep repeating, right? So 2 up to 5, back to 2, down to minus 1, back to 2. And so then we'd have to add some more points here. Oh, I might have to get rid of my initial xy. Let's just move that over, just so we got some more space here. So we got 1, 2, 3, 4. And then we have these new points, right? Going up here, back to the middle, back down, and back to the middle. And we can add that little arrow there. Same thing, we can go back in the other direction, right? We could go back here, 1, 2, 3, 4. These would be minus 90, minus 180, minus 270, minus 360. A little tricky to get them all written down here, but we got it. And this would go down to minus 1, back to the middle, then up, then back to the middle. So if we extended it back this way, we would go like that. And so we can see here how, oh, a little sharp up there, let me round that out. There we go. And so we can see here how we would have multiple copies of this sine graph. Right, again, one period here would be this section. This is one period, which is equal to 360 degrees. It's one cycle, one lap around the unit circle. But we could keep going in either direction, and sometimes we'll be asked to graph more than one period. All right, so here's an example right away. Let's go ahead and sketch this graph, and I would like you to sketch 3 periods. It's probably easiest to sketch them 3 to the right, but you could do 1 to the right, 1 to the left, and the initial period, whatever you want. So go ahead and pause the video and give it a try. Okay, so assuming you gave it a try, let's go ahead and start with, again, our basic values. We're going to grab 0, 90, 180, 270, and 360. 0, 1, 0, minus 1, and 0. And then here, we need to take those y values and multiply them by -2, and then subtract 1 from them. That's how we're going to get the new table. Now, x stays the same, so 0, 90, 180, 270, and 360. And for the y values here, well, 0 times -2 is just 0, and then -1 is -1. This will be -2 minus 1 is -3. -1 times -2 is +2. -1 is back to 1. And then 0 is back to that -1. All right, so we go up as high as 1 and down to 1, 2, 3, minus 3. 1, 2, 3, 4. Okay, this is going to be 360. And then we can go 1, 2, 3, 4 this way. And then why not? Let's just keep extending another 1, 2, 3, 4. So 360, this will be 720. And then this will be another 360, which is 1080. All right, so let's go ahead and plot our points. So at 0 degrees, we have -1. Then we have -3. Back to -1. Up to 1. Back to -1. So the initial sketch looks like this. If we just had to do 1 period, we could just throw some arrows on it and call it a day. But unfortunately, we're asked for 3 periods. So maybe we'll put an arrow on this end, but here we have to continue the pattern. So you could think of it as going down to the bottom, back to the middle, up to the top, back to the middle. There's another period. Bottom, middle, top, and middle. It's kind of like a little game here, right? You just repeat the pattern, put an arrow on the very end, and now we have 3 periods of the graph. Again, this right here, this is 1 period, and then we extended it to make a total of 3 periods. All right, let's go ahead and do another graph. We're going to do 4 cos theta plus 3. We're going to sketch 1 positive period and 1 negative period, and we're going to make this one tough. We're going to do it in radians. So pause the video and give it a try. All right, this one is tough. I'm going to help us out here. So our initial XY table is going to look like 0, but then instead of 90 degrees, that's pi over 2. Instead of 180 degrees, that's pi. Then we have 3 pi over 2 and then 2 pi. Those are our key points, but written in radians instead of degrees. Now the y values are still the same for cos. It's 1, 0, minus 1, 0, and 1. All right, now we need to get some new values. The y is going to be multiplied by 4 and add 3. Okay, the x stays the same, thank goodness. 0, pi by 2, pi, 3 pi by 2, and 2 pi. 1 times 4 is 4 plus 3 is 7. Okay, then this will be 3. 1 times -1 times 4 is -4 plus 3 is -1. 3 and back to 7. Okay, 1, 2, 3, 4, 5, 6, 7. There's the top. There's the middle. There's the bottom. 1, 2, 3, 4. So this is pi over 2, pi, 3 pi over 2, and 2 pi. So let's go ahead and plot those points. At 0, we're up at 7. Then we're down here. Then we're down to the bottom, back to the middle, and back up. So remember, cos has that nice valley shape. But now we have to keep going, one positive and one negative period. Now I think the negative period is a little bit easier because we could just count this way, and these are all just negative values. So this would be negative pi over 2 if you wanted to label them. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Again, we start at the top, then we go to the middle, down to the bottom, back to the middle, back to the top. Making that nice valley shape. And then if we wanted to extend it one period to the right, well, here the values get a little tricky, but if you wanted, you could 1, 2, 3, 4. You could cheat it a bit, and you know that this is just going to be 4 pi, because another rotation around the circle is going to be another 2 pi. 2 pi plus 2 pi is another 4 pi. You don't necessarily have to label each one. I mean, if you were asked to, it might be good to find them, right? So the next point would be 2 pi plus pi over 2, which if we do fractions will be 5 pi over 2. So it might be nice to know that this point is 5 pi over 2, but as long as we have a couple of the points labeled, the rest of it I think we're good to go with. So let's go middle, and then bottom, middle, and oh, it looks like we're going to go over our table. That's all right. Make that nice valley shape. Throw an arrow on it, and there we have 3 periods of the cos graph. Well, I think actually we did more than we were asked. We were asked to just sketch one positive period and one negative period. That's okay. We got some extra. So this is, we actually did 2 positive periods and 1 negative period. So as long as you got up to here, that's good, but this is some bonus. Okay, let's go ahead and take some notes on this. So what we're doing today is sketching sine theta, sketching y equals sine theta, and y equals cos theta. And the most important thing to do is to have the base graphs. So this here is sine, middle, top, middle, bottom, middle. We have a nice wave shape. It goes up to 1, down to -1, and each one of these is a nice evenly spaced all the way to 360. So 360, this is 90, this is 180, and this is 270. And then for cos, it's the same idea. It still goes up and down to the same value, so it still goes up to 1 and down to -1. And we still space it out like that with the 360. But we start at the top, then go to the middle, then the bottom, then the middle, then back to the top. Something like that. And then these are still the same 90, 180, 270. Now again, technically these graphs continue, so it's nice to put some arrows on them just so that we know that they continue. And from those base graphs, we can just use transformations to sketch everything else. So here we have one period of y equals -1/2 sine theta plus 4. Go ahead and pause the video and give that a try. So assuming you gave it a try, you should have the following points for your graph. 0, 90, 180, 270, 360. And the y values should be 4, 3.5, 4, 4.5, and back to 4. Now this is a little tricky to sketch just because the points are really close together. So I'm going to try to go like this, 1, 2, 3, 4, 5, just so we can get a little bit of spread there. And then here we got 1, 2, 3, 4, so this is our 360. This is 90, 180, and 270. Okay, so now we've got 0 and 4 up there. The 90 is going to go down just to 3.5, back to 4, up to 4.5, and then back to 4. So our graph will look something like this. Now if you notice, this sine graph is very small because the 1/2 has made it smaller. Additionally, if you look and compare these two graphs, the initial sine graph over here goes up to start, but this sine graph goes down to start, and that's because the negative sign has done a vertical reflection. And of course the +4 has moved the whole thing up 4, where the initial one was kind of along the x-axis here. This is now up along the 4. All right, so for extra practice, you can definitely work on worksheet 9 and 9.5. And then any things to remember, there are some terminology that we were talking about here. So period, that means one cycle of the graph. Additionally, if you notice, I was kind of talking about where the graph was centered along. This is sometimes called the midline. We'll look at some of these more terms later in other videos, but the midline here, that's kind of like just the middle of the graph. So the midline is the middle of the wave or valley. The middle of the wave. And of course, we always want to remember arrows. Arrows. These graphs continue on to negative infinity and positive infinity, so we need to make sure that we have arrows on those graphs. Oh, and maybe even another thing to remember is make them smooth. A smooth graph, right? You want to make sure that these look nice and wavy. We don't want them to be all sharp and pointy. So do your best to connect the dots in a nice smooth way. All right, hopefully you enjoyed this video, and as always, thanks for watching.